In this video, we'll talk about the addition rule and complements from a statistical standpoint, but first we need to go over some vocab. So two events are disjoint if they have no outcomes in common. For example, if I choose one student and I'm interested in are they seniors, are they freshmen, those are two disjoint events because one student cannot be both a senior and a freshman. Another name for disjoint is called mutually exclusive. So a student who is a senior and a student who is a freshman would be considered mutually exclusive events. Now we can see a Venn diagram of this. Mutually exclusive events would be circles that do not overlap. So in this circle here, the green circle has the numbers 8 and 9. I think these are chips in a bag. And the purple circle has the numbers 0, 1, and 2. And notice that 3, 4, 5, 6, 7 aren't in either circle. But we can say that the event E and the event F are disjoint. They're mutually exclusive. There's not one number that's fitting in both the purple and the green circle. So the probability of picking event E is 3 out of 10 because there are 3 numbers in circle E and there's 10 numbers total. The probability of choosing a number in circle F is 2 out of 10 because there's 2 numbers in circle F and 10 total. The probability of picking a number that's either in E or in F is 5 out of 10. Now I can also use what's called the addition rule because I've already calculated the probability of E. That's where this 0.3 comes from. I've already calculated the 0.2. That's where this 0.2 comes from. And I add them together. So I can either find all the numbers that are either in E or in F, in other words, 3 plus 2, and then divide that by 10, or I can just simply add these probabilities that we've already calculated. So as long as my two events are disjoint or mutually exclusive, then all I need to do to answer the question, the probability of E or F, is to add the two separate probabilities. And it doesn't really matter if I've got 2 events or 3 events or 4 events. I still am just going to add them together, add the individual probabilities together, as long as all of these events are disjoint. Now here's a probability distribution, a frequency distribution with a relative frequency chart in it. It is a probability model because all of the probabilities here are between 0 and 1, and when I add them up, they do equal 1. So now I can answer a question like, what's the probability that a randomly selected housing unit has 2 or 3 rooms? The word or means we're going to add. So the probability of picking a unit with 2 rooms plus the probability of picking a unit with 3 rooms. And that's how we get 0.125. The probability of picking a unit with 1 or 2 or 3 rooms, well, they're all disjoint, they're all mutually exclusive, so we add the 3 individual probabilities together. So in general, though, not all events are disjoint. There is sometimes some overlap. So in general, we have to not only add the individual probabilities together, but sometimes we have to subtract. And the reason we have to subtract is because there might be some ways of satisfying event E that would also satisfy event F. So essentially we're double counting. So here is 2 dice, and we see all the different outcomes when we roll 2 dice. Here I get snake eyes, a 1 and a 1. Here I get a 2 first and a 3 second. This question right here is asking us to find the sum of the dice being less than or equal to 5. Also, we have an event, the first die is a 2. So this row right here, the second row, is all of the events or the outcomes where the first die is a 2. The sum of the dice being less than or equal to 5. Let's see, here's less than or equal to 5. There's less than or equal to 5. Here's another less than or equal to 5. We're trying to find the probability that we would pick a first die with a 2 and also the sum of the dice being less than or equal